Financial Maths video is on instalment savings or annuities. We'll be using a number of formulae from the log tables for this. First of all, from page 30, we've got our final value formula, and on page 22, we've got Sn equals a bracket 1 minus r to the n over 1 minus r, which is the formula for the sum of geometric series. So first of all now, what do we mean by instalment savings? So instalment savings involve deposits made at regular intervals, which each accrue different amounts of interest because they're invested for different durations. So for example, I deposit a certain amount every month with a particular endpoint in sight. So let's look at an example. So Cathal invests €100 at the start of each month. The AER is 2%. How much will be in his account at the end of 3 years? Okay, so the first thing to notice here is that my units for time are a little bit all over the place because he's investing money at the start of each month, but my interest rate is a yearly rate and the duration of the entire investment is a yearly number as well. So I'm going to have to try and sort all that out first of all. So the monthly principal is 100. The number of months the investment runs over will be 36. And for monthly rate, I'm using this formula from an earlier video to calculate R. So I'll fill that formula in and then I'll do a bit of manipulation to get R by itself. Pause the video here and try that yourself. So I'm getting a big long decimal here, 0.001651588302. Normally, if we were just getting the monthly rate, we'd change this back into a percentage, but I'm going to need to use it in decimal form for my calculations anyway, so I'll leave it as it is, but I will round it off slightly, and I want to round it off to about 5 decimal places. In some questions, you'll just be given the monthly rate. In some questions, they'll tell you what to round the monthly rate off to in terms of number of decimal places. If not, then do what I've done here and keep about 5 decimal places in the decimal version. So now I'm ready to go ahead with my calculations. So really in this question, because Cathal's investing 100 at the start of every month for 3 years, I've really got 36 individual investments going on. Let's start with the first one. I'm going to call this month 1. So in this case, he's putting 100 into the account. It's going to stay there for the full 3 years and earn the full 36 months worth of interest. So the final amount for this first monthly investment is going to be 100 bracket 1.00165 to the power of 36. And this is just using my F equals P bracket 1 plus I to the T formula. And instead of writing in 1 plus 0.00165, I've just put it all together as one value. Really more to save on space than anything else because these calculations can get a bit long and cumbersome. So that's month 1 done. Now on to month 2. So the amount that he invests in the second month is going to go into the account for almost the same amount of time. It'll be 1 month less, so it'll be 35 months that it'll be invested for. And as we go along, we're adding up the final values for those monthly investments because at the end of the investment period, he's going to have all of this money in his account. Now, if I was to do each month individually, we'd be here forever. So at this point, we kind of tend to do ... and then work on to the last month. So time passes and I'm on to the 36th month and I'm at the start of that 36th month and the last €100 is being invested. So to find out how much it will be worth at the end of the 3-year investment period, I just apply 1 month's worth of interest. Just a little note at this stage to watch out for the phrasing of the question because sometimes in the question they'll have it put so that the investment is occurring at the start of the month, like they have in this case, but it can also happen that the investment is occurring at the end of the month. And if that's happening, you might find that your last investment, for example, might not have an opportunity to earn interest because it's coming in right at the very tail end of the investment period. And my goal now is to figure out the final value of the entire investment by adding up all these individual values. And this is where our formula from series comes in. And this will allow us to add up all our values. We'll be using our calculator in a while to type this calculation in, and just in terms of making things easier for ourselves, because it's going to be a fairly jam-packed formula anyway on the calculator, what I'm going to first of all do is I'm going to take this information here that I have about the investment and I'm going to rearrange it. So I'm going to put this piece of information first and this piece of information last. So I've just literally taken this line and reversed it. And this is just for ease of calculation of the sum of a geometric series. Generally, in a question of this type, try to have the lowest power first and the highest power at the end. So now I just need to identify the components of the formula for the sum of the geometric series. So I need to find out my A, my R, and my N. And just watch out here that R here does not mean the monthly rate. It means the constant of multiplication from one term to the next in the geometric series, and n means the number of terms in the calculation. So my first value here is going to be a, because a is the first value in the geometric series. R is the common ratio, so I need to figure out how I'm getting from one term to the next. And in this case, it's easiest to find that by looking at my last two terms and seeing what did I need to multiply this term by to get to this term. Well, I've got an extra 1.00165 because the power has increased to 36. So that's my R value in this case. If you ever get a bit confused about that, well, don't forget, you can always take a term and divide it by the previous term to clarify that value for R. And there are 36 terms in my calculation, so n is equal to 36. So now I have the three values that I need to get Sn. Okay, so filling in the top first. I'm first of all filling in my a value. So I've got my 1 minus r, and just watch out, that power of 36 needs to be inside the bracket. Okay, you can see that it's inside the bracket here in the formula. And then in the bottom, just 1 minus r. And just take care that when you're typing this into the calculator, that you type it in exactly as it looks here on the page. Any variation and you risk the question's solution not coming out correctly. So pause the video here for a second, do this calculation yourself, and then check and see if it matches my answer. Okay, so my final solution here is €3,712.04. And again, because this is my final answer and it's money, I can round it off to 2 decimal places. And just a little follow-on question here. What is the total interest earned on the savings? Pause the video here and have a think about this one yourself. And then when you've got a solution, play and see if you're correct. So the final value of my investment, as we just saw, is €3,712.04. The total invested in this case is 100 times 36, which is 3,600. And then all I have to do to find the interest earned on savings is simply subtract. And in this case, that's €112.04. So here's a question for you to do. Bob invests 50 at the start of each month at an AER of 3% for 2 years. How much would his investment be worth at the end of this time? Pause the video here, do this question yourself, and then play and see if you're correct. And if you get stuck at any stage, maybe just play a little bit to nudge yourself along and then pause again. So first I need to match my time units. The monthly principal is 50. The number of months for the investment is the number of months in 2 years, so that's 24 months. And then I have to find the monthly rate. So I'll fill in that formula, and that'll be the 12th root of 1.03 minus 1. Make sure that minus 1 is outside that root. And I'm going to give 5 decimal places on that. So R equals 0.00498. Oops, looking at the wrong question there. Actually, it's R equals 0.00247. So now I'm going to look at the structure of his investment. Looking at month 1's investment first of all, I've got 50 times 1.00247 to the power of 24. Looking at month 2, same thing, but this time to the power of 23. I'll be adding as I go along. And finally, I'll have month 24. And that's just in for 1 month, so it only gains its interest once. And now that I've got that written out, I'm just going to write it in the other order. And again, this is just for ease of calculation on the calculator in a minute. So now I'll want to add those all up using my sum of geometric series formula. So my A is my first term in the calculation. R is my common ratio. In this case, that's 1.00247. And N is the number of terms, or the number of months. Okay, so now it's time to fill into the formula. So here's my subbed-in calculation. So in this case, the final amount of the investment is $1,237.76. Take a second to work out the interest earned. And in this case, that's $37.76. Okay, so now let's look at the second example. And in this example, we're going to be working backwards from our final amount to find out how much we should be investing every month. So Finbar wants to have €10,870 in 4 years' time. The quarterly rate is 1.5%. How much should he deposit monthly to meet this target? Again, just like in previous questions, I need to make sure that my time units match. So I'll match my time units, and since he wants to deposit his money monthly, that means that I'm going to aim for monthly in terms of my units. I'm going to call the monthly investment amount P. The number of months the investment is taking place over is 48. And I have to calculate the monthly rate. Now this time I'm not being given the AER, I'm being given the quarterly rate. So the quarterly rate is the amount of interest that I earn every quarter. So obviously there's 4 quarters in a year, so I'll earn this interest at 4 times over the year. And that'll influence how I set up my formula to work out monthly rate. So as I said, a quarterly rate is applied 4 times in the year, and a monthly rate is applied 12 times in the year. So this is what the formula will look like. So I'm filling that formula in. And here's that R equals 0.00498. Just watch out as you type this into the calculator that you press the right arrow enough times to get out of the root before you put in the -1. You really need to take care with your calculator in all of these calculations. So I'll set it up in a similar way to before. I'll start with month 1. I don't know the amount being invested, but the rest of the calculation is the same as before. So it's that F equals P bracket 1 plus I to the T formula that I'm using again. And that's my month 1. For month 2, I'll just drop the power to 47. Of course, these are all getting added as I go along. And then I'll skip on to month 48. And then just like before, I'll just reverse it, starting at the month 48 value and working on to the month 1. And then at this stage, I need to identify the values that I'll have to fill in to my sum of a geometric series formula. So that first term is my A, R is my constant ratio, and N equals 48. So I'm going to fill into my formula, but this time don't forget I have another piece of information. It's my target value for my investment at the end of the 4 years. So just to glance back to that again, that was 10,870. So I'll be filling that in here for SN. Okay, so the rest of the formula then looks like this. I put my A value in first of all. Don't forget it's got that P as part of it. And then I've got for my 1 minus R to the N, 1 minus 1.00498 to the power of 48. And then on the bottom, I've got 1 minus 1.00498. And then off I go to, actually no, I can't go to my calculator just yet. I need to isolate this P value here. So I have to get this P value by itself, so I need to do a bit of manipulation. So effectively, whatever's in the bottom of my fraction will come up and multiply by the 10,870. And whatever, aside from the P is on the top of the fraction, is going to go into the denominator. Phew. Right, and now we go to our calculator and type that in. And again, just take care typing these kind of calculations in. They can be a total pain because there's so many bits in them, but just type it in exactly as you see it and always start by pressing the fraction button. My solution in this case is €200.03. Sometimes questions will ask you to round off to a certain degree here, but I'm going to take that answer of 203 cents as my final answer. Okay, so a question for you. Rose wants to have €20,000 in 5 years' time. The AER is 4%. How much should she deposit monthly to reach this goal? So pause the video here, do it yourself, and then play and see if you're correct. And again, like before, if you need a bit of a nudge, play a bit, and then pause when you're comfortable to proceed. So first up, we'll match our time units. We'll call our monthly investment amount P. The number of months in this case is just 5 by 12, which is 60. And we'll find our monthly rate. And I'm using this formula this time. So I've filled in my value. I do a bit of manipulation, and I'm going to give that monthly rate to 5 decimal places. Now I'll start looking at the structure of her investment. Don't forget that in each case here, for each month, I'm using that formula F equals P bracket 1 plus I to the T. So here I have month 1, my amount that's invested monthly, times 1.00327 to the power of 60. Then month 2, P times 1.00327 to the power of 59. And then dot, 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 over to my last month, month 60, which is P times 1.00327 to the power of 1. I'll write the statement in reverse. And then since I'm using my formula for the sum of geometric series, I'll note my A, R and N. So I've got my formula. Don't forget that Rose's goal was to have €20,000. So I'll put that in for SN and then I'll fill in the rest of the formula. A first of all, followed by 1 minus R to the power of N, over 1 minus 1.00327. Then a little bit of rearrangement to get P by itself. Again, don't forget, effectively what will happen is that the denominator information here will come up and multiply on the top, and whatever's in the numerator will end up in the denominator. So my rearrangement is complete, and now it's simply a case of going to the calculator and carefully entering everything. And as always, just take care with it and be super careful that your power is inside the bracket. So in this case, the amount that Rose needs to deposit monthly to reach a goal of 20,000 in 5 years' time is €301.26. And just one last note to finish up on. which is that annuities are the same as instalment savings from the point of view of calculation.